today we are going to do some quick notes over rational exponents. So if you think about our rational parent function or a rational equation, what that means is a fraction. And so what we can do is we can actually represent exponents as a fraction, specifically when we have a radical. So if I have x to the nth power, this can actually be represented as a rational exponent where I have 1 over n. So n is actually called my index. And you actually do know what this is. So when we have no index written, we assume it's a square root, which means our index is 2. When we have a cube root, the 3 would be out there, and that would also be our index. Our index would be 3. So if we ever have a radical, we can write that exponent as 1 over my index. That means the same thing. And we're going to see what that looks like down below in a moment. The other thing we might see sometimes is if I have a radical, but I also have a power either inside that radical or outside that radical, and we can represent that as a rational exponent as well. The index is still the denominator, and my other power becomes the numerator. And again, that numerator can either be outside the radical or inside the radical. So let's look at some examples. Starting with example 1, we are going to rewrite these radicals as rational exponents. So here I have the square root of x. And when it's not written, we're assuming that our index is 2. So this is going to be x to the 1/2 power. They mean the same thing. If you ever see x to the 1/2, you can rewrite that as the square root of x or vice versa. Okay, let's look at b now. I have the cube root of 6x. So this is going to be the same thing as 6x to the 1/3 power. And what's important here is that your 6x is going in parentheses because both the 6 and the x were in your radical. So we need to clarify that the 1/3 power is being applied to the 6 and the x, not just the x. Okay, looking on to c, I have the square root of x to the 5th power. So I'm going to have one of these types of exponents here. So x is all that's inside my radical. My denominator is the index. Remember, if it's not written, we're assuming it's 2, so that's going to be my denominator. And then my other power is 5, so that's my numerator. So this is x to the 5 over 2. Okay, let's look again at d. So again, similarly, I have an index on my radical of 3, and it's being raised to the 4th power. 3x, both parts were in my radical, so I need it in parentheses. And my rational exponent, my denominator, is going to be 3 because that's the index of my radical, and my numerator is going to be 4. Let's practice this the other way around. On this last row, example 2, I'm given rational exponents, and I'm going to be rewriting them as radicals. This first one, a, x to the 1/3, that is going to be the cube root of x. They mean the same thing. b, x to the 1/2, that is the square root of x. Now, c and d, we have 2 ways we can write these, and I'll show you both ways. So starting with c, 7x. 7x is in parentheses, which means both the 7 and the x are going to be inside my radical. My denominator of my exponent is 3, so that means the index of my radical is 3. And now this 4, remember, we have 2 places we can put it. We can say this whole thing is being raised to the 4th power, or I can put it inside my radical, again, as long as my 7x is in parentheses. All right, and then last one, d, I have 3x to the 2/3 power. So again, this is going to be a cube root. 3x is inside, and I can either raise that whole thing to the 2nd power, or we can say the cube root of 3x and the squared is inside the radical. Either way is acceptable. Okay, and this is just a brief introduction into rational exponents. We will go into them more in depth later on, but the key takeaway today that I want you to recognize here is that if you see x to the 1/3, that just means cube root. And if you see x to the 1/2, that means square root. So these are interchangeable. They mean the same thing. Math is full of things that mean the same thing but look different.